Our presentation is on the non-relational database system ElasticSearch. So these are the programming languages supported by ElasticSearch. We have Java, Python, and the rest you can see there. And then also ElasticSearch supports 34 different text languages. If you want to see the complete list, you can click on the link right there. As for the installation, we provided 3 different processes if you want to use the Windows, the Mac, or the Linux process. So for the Windows installation, you're going to first search ElasticSearch in your web browser. Click on elastic.co, go to their products, click on the box under Elastic Elk Stack, then download and get started. There will be 2 different boxes, one with ElasticSearch, and there's a Windows button you're going to click on and do the same for Kibana. So this is what it'll look like. So this is ElasticSearch's website. You're going to download the 2 zip files. That's how Windows installs them. After that, I created Elastic Stack folder in my C directory to store the 2 zip files, and then I unzipped them into my under users in my name because Kibana has some files with a really long path, so they might not be unzipped correctly if you put them too far down a path. Also, extracting files from Kibana can take quite a bit of time, so plan for that. Okay, next, in order to start ElasticSearch, you're going to go to your command prompt and type in elasticsearch.bat. So just go into your bin directory in ElasticSearch, wherever you stored it. It takes a second as it gets running. Should start to look like this after a second. And then you know it's done when it says Kibana Task Manager. So you're going to check by going to localhost 9200, and it should output this right here. Next, in command prompt, you're going to go into your bin folder in Kibana and run kibana.bat. And again, Kibana takes quite a bit of time to get running, so don't be concerned when it doesn't look like it's doing anything for a while. As you can see, the process takes quite a bit of time. So it'll start to look like this after a while. And it's still at this point is not done. You'll know it's done after it says server running at 5:06:01. So after that, you're going to go to localhost 506.01, and then you should see this screen. This is the home page for Kibana.
And now we are going to install Kibana and Elasticsearch on Linux. I just want to preface this by saying that I would really only recommend more experienced Linux users to go with installing Elasticsearch and Kibana on Linux. It can be pretty frustrating, time consuming, and a bit tedious. The instructions I'm about to give only apply to Ubuntu. Although they may seem pretty simple, other distributions may require some extra um, special footwork to get things up and running properly. And with that, it's also highly recommended that you use a Linux distribution with a GUI, because Kibana is obviously it's a data visualizer for Elasticsearch. So if your Linux distribution didn't have a GUI, well, what's the point of having Kibana? Um, so otherwise, you'd have to use the curl command to just pull out or get raw data from Elasticsearch, and it can be kind of hard to read that. Um, so, anyways, let's get into it. Installing Elasticsearch, it's pretty straightforward. You download the DEB package and the hash for that package. You compare the two using the SHA-SUM command, and then if it matches, you just install it. The same goes for Kibana. That's pretty much it. It's pretty straightforward, and the installation process, at least in my personal experience, did not take as long as getting it installed on Windows or macOS. And then starting Elasticsearch and Kibana are both very similar. Both commands start out with sudo system control start, and then you either say Elasticsearch or Kibana.service, and then they start, and then you can check their status using this command, and the little green circle here indicates that everything is all good from Linux's point of view. Now, even if the green circle is present, the service may not be running for whatever reason, in which case you can run the command service Elasticsearch restart or service Kibana restart to restart the service, and then things should be up and running. Um, I would also recommend starting Elasticsearch and then Kibana, because Kibana runs off of the data provided by Elasticsearch. I've never ran them in reverse order, but just to be safe, I would probably just do Elasticsearch first and then Kibana. So as you can tell, it's not too complicated getting things up and running on Linux, but of course, if you're running anything other than Ubuntu, or anything else that won't take a .deb for an installation, you may have to refer to Elasticsearch's website for more details on how to get it installed properly. And with that, let's go to the macOS installation. And now we will get a brief demonstration on how to execute all of these commands. All right, now let's go over the basic usage of Elasticsearch and Kibana. So getting started, I just want to get something out of the way, a misconception some of y'all may have in y'all's minds. Kibana and Elasticsearch are not the same thing. Elasticsearch is the NoSQL technology, but Kibana is what visualizes all of the data within Elasticsearch. Without Kibana, Elasticsearch may not be as dazzling to a lot of users. It has a lot of really excellent data visualization tools. And I'd almost go as far to say that Elasticsearch isn't the same without Kibana. Although you don't have to have Kibana to use Elasticsearch, it's just not as convenient. Um, you'd have to use just pretty much straight up HTTP GET commands like this curl HTTP localhost 9200. Um, it's not pretty. It's nowhere near as pretty as what Kibana can provide. But if you don't want to use Kibana, you can just interface with Elasticsearch directly. So using Kibana, we're going to talk about a few of the primary interfaces that users can use to look at their data, not necessarily manipulate it, but really understand what's going on. So the first one that we're going to talk about is Discover. And this is just a little snapshot of the Discover tab for the homework that y'all will actually be doing. This is what it should look like after you get the data imported. It shows raw data fields, sources, and the fields themselves. I know it's really tiny to read, but like birthplace, favorite color, gender, name. And then you can also search up here in the search bar. You can find, every search entry where, for instance, their age is 22, for instance. And your queries can get very complicated, just like in MySQL, but they can also be pretty simple. And you can also apply global filters that just kind of follow you around everywhere. You can save queries similar to how a view works in MySQL. Um, and you get search results back incredibly quickly. If you do some of the demo projects, I encourage you to do that, by the way. It's really great working with a lot of data as opposed to just the 12 data points that we provided in the homework. Um, you'd be amazed, really, how fast Elasticsearch can bring back all of the search results. It's quite incredible, and you can also project only showing certain fields. That's a nice touch. And then the dashboard. This is where you can add a lot of data visualizations. It's really customizable. It's interactive. Um, if you can think of a chart, any chart, Kibana probably has it ready to go. It's very easy to get set up. You'll actually be setting up um, data visualizations on your own in the homework. It's not that hard, I promise. And it can work with lots of different types of data. The next thing is Canvas. This is really great for official presentations. It looks incredibly clean. It's very easy to read. You can basically customize it down to the pixel. If you want it to look exactly like this, you can make it look exactly like that. It can also take in visualizations directly from the dashboard, and you can put them right into the canvas, which is really convenient, especially if you have a visualization already made. But you can also find those visualizations in the Visual tab, but we're not going to go over that in detail today. And you can also input direct Elasticsearch queries if you want to just have a more raw output. But regardless, Canvas is a very, very good visual tool for really any user. Okay, so the next one is maps. If you have like a latitude, longitude, or a geolocation such as state, county, province, really, you name it, Kibana probably has it. This is just of the United States, but you can if your data is set up in a certain way, you can look at the entire world. You can look at just specific countries. Um, their mapping software is quite incredible, and it's very, very powerful. Um, I didn't really get much into the customization of it, but similar to the dashboard and all the other data visualizations, you can really make it yours and make it how you want it to be. And so spaces, this is, think of it kind of like a personalized dashboard for a certain group of users. It shares the same data across the entire index or across all spaces. It uses the same index, but it just, depending on who you are, you may not need to see certain information or you may not be allowed to see other information. So a space could be created, for instance, for the marketing team, for the executives, for developers. Um, it's really sort of just, it is what you make it. You can control views of certain data to certain groups of people. And then importing data into Elasticsearch, it's actually considerably easier than you would think. It's really just drag and drop. It can take lots of different types of files like JSON, CVS, log. Y'all will be actually importing a pre-made CSV file um, for the homework for this lab or for the homework for Elasticsearch. And it shouldn't be too hard, but you'll see really just how easy it is. So the next thing we're going to talk about is cases and industrial adoptions. Elasticsearch is very popular because it is very fast. It's very scalable. For the homework, it's only 12 data points, but for some of the demos, it's upwards of a few thousand. Um, and it can index a lot of different types of data, latitude, longitude, numbers. It can aggregate a lot of different types of information. You'd be surprised. Poke around there, around the demos, and you'd be surprised what you may find. And in industry, as you can see here, there's a lot of different just examples that we have listed out here. But website search would definitely be a great one. Websites have tons of different, especially a shopping website like Amazon, for instance, they have tons of different products. And narrowing it down using Elasticsearch would be great because it's very fast, it's very scalable, and what's not to like? Um, and you can read the rest of these here, but whenever you look at the demos and whenever you import our data, I think you'll be able to see just how versatile Elasticsearch really can be. And the next thing we're going to talk about is limitations.
So there are many limitations with Elasticsearch, just like any other databases. But today I will talk about some of the important limitations known with Elasticsearch. So one of the biggest setback probably for Elasticsearch is a really expensive update. So whenever you update an Elasticsearch database, you need to delete the entire documents and reinsert it as a new document. So it will eventually cost a lot of time for if any firm doing their database update. The second setback would be not a real time or eventual consistency. So what does this mean? It means when you put the data in, it will only be available after 1 second, and this process is known as like a refresh wake up every 1 second by default, and only after that it makes the data searchable. So these limitations also lead to the limitations of supporting transactions and rollback because there's delay in the system, and when you're doing transactions you don't want that to happen. So is it clearly that this system does not design for transactions. So one of the setbacks is data loss. So for any firms that use network partitions, they might be facing these data loss problems, which a network partitions isolating a primary can cause the loss of insert document. However, this error is known as pretty hard to recreate, about 1 in 10 runs, and sometimes in a rough case, 20% of the documents can be lost with the primary isolating partitions. So machine learning is pretty a big topic today, and every developer want to have a big good database so they can train their models in. So Elasticsearch also have some limitations regarding these subjects, and the first one is the hardware support. So the CPU must support the streaming SMID extensions 4.2 instructions. So which means this will only works on those type of CPUs. So if you're running an older computers, you might require some tweakings before you can actually start doing your machine learnings. Also, one thing to note that you shouldn't run this one on Windows if you're doing machine learning because of the CPU scheduling improvements, which only applies to Linux and MacOS. What is CPU scheduling improvements? When there are many machines learning job running at the same time, there are insufficient CPU resources, so the virtual machine performance must be prioritized so search and indexing latency can remain acceptable. So to that end, when CPU is constrained on Linux and macOS environment, the CPU scheduling priorities of native analysis processes is reduced to favor Elasticsearch virtual machines. And it only supports for Linux and Mac OS. So it's really a setback when you're using Windows. The next limitations is the categorizations using English dictionary words only. So categorization identified static parts of unstructured logs and group of similar message together. So the default categorization tokenizer assume English language as the log messages. So if you want to apply your own language, you need to have some tweakings, which is pretty complicated in this situation. And if you're running forecast in machine learning, then there are also some limitations. So the first one is if there's insufficient data to generate any meaningful predictions, an error will occur. And one more thing is you can only generate 3 forecasts per anomaly detection job. So anybody doing a forecast machine learning must have known about these limitations. So when we talk about any database, security will be always the top priorities, right? However, there are some limitations in these sections, and it must be noted by developers to be able to apply correctly. The first limitations that everybody should know is that Elasticsearch doesn't support, cannot guarantee any third-party plugins. So Elasticsearch plugin infrastructure is extremely flexible, like in terms of what it can be extended, while it open up Elasticsearch to a wide variety of additional functionalities. But when it comes to security, Elasticsearch cannot guarantee you anything, because each developer need to do some intensive testing to verify that their database or their system does not have any vulnerable when applying a third-party plugins. And one more security limitation is index and field names. So calling a certain Elasticsearch APIs so when you're using aliases for index and field names, by doing that, they leak the information regarding to the fact that the data stream or the index doesn't exist. So why the user is not authorized to know anything about the data stream or indices. And when we talk about multi-document APIs, calling a certain Elasticsearch API on an alias can potentially leak information about indices that the user isn't authorized to access. So for example, when you get the mappings for an alias with the mapping API, the response included with the index name and mapping for each index that the alias apply to. So therefore, developer need to avoid using index and field names that contain confidential or sensitive information. So one more thing in security limitations is the change in wildcard behavior. And Elasticsearch cluster with the security features enabled by the O/_all wildcard and all other wildcards to the data stream indices and index aliases that the current user have privilege for, but not for all data streams indices and index alias on the cluster. So you need to be really careful with this.
Elasticsearch is different than SQL in a few different ways. So we're going to compare the two right now. Based on terminology, these are more of the similarities between the two. Elasticsearch uses fields in place of MySQL's columns, documents in place of rows, indexes basically mean the table of MySQL, and then schemas don't really have a direct synonym or term used for Elasticsearch. And then we have instances of clusters and federated clusters in Elasticsearch, which compare to catalog or database in MySQL and clusters again in MySQL. So while these don't directly correspond to their counterpart in MySQL, they're the closest equivalent, and it makes understanding how things are arranged and stored in Elasticsearch a little bit easier if you're familiar, which we all are, of how MySQL groups and stores data. So the basic distinction between the two, though, is that Elasticsearch is a NoSQL database. Therefore, there's no relations, no constraints, no transactional behaviors, no joins. With all of these, Elasticsearch is a lot easier to scale than MySQL, which we'll talk about in a little bit. Elasticsearch prevails over MySQL with these search methods. So if you're going to search something based on relevance, Elasticsearch has a ranking system built into it. So certain keywords and phrases have a relevance ranking that results will pop up based on how, again, relevant they are. It's like how Google gives you the most relevant searches first when you're like you have TCU and TCU's website comes up. Elasticsearch can also give you searches that you are looking for, even if you misspell some of the words. MySQL is not good for searches such as this. Full text search, that's what Dr. Wei was telling us about earlier in the semester. MySQL doesn't really have a good way of storing huge blocks of text, but Elasticsearch can hold entire novels, pages of information, and easily search up stuff like that. And then synonym search, phonetic search, and log analysis. These are all great with Elasticsearch, whereas MySQL falls a little short in doing this. We don't have a great way to search for synonyms of words we input or have any sort of phonetic way of retrieving information. So this is another benefit over MySQL. Elasticsearch is near real time. So whereas queries in MySQL can take a little bit of time to return, Elasticsearch is almost in real time. You search it and it comes up. And part of this, another benefit is that my Elasticsearch scales very easily. Elasticsearch is capable of handling large amounts of data to scale horizontally with shards assigned to nodes in a cluster. As shown right here, you see that there's an index, and then within those indexes, it references shards, which have IDs. So all the data and is stored such as that. That makes it quicker to search, and it has all of those benefits previously with how Elasticsearch prevails. The relevance, the full text, synonyms, phonetic, all of those things are because of how the documents are stored. Similar to an index in a book, yes. And then the visual difference, here is how you would insert either, this is asking for a query in Elasticsearch, and then we're very familiar with the MySQL workbench, how everything looks there. So if you want any more information about Elasticsearch, this link here will take you directly to elastic.co, and the most frequently asked questions are in there.
And just as a quick ending note, thanks for getting all the way through this video, and we hope that you choose our NoSQL technology to do your homework 6 for. If y'all have any problems, y'all can always reach out to Lauren, or myself, Matthew. And yeah, thanks.